U.S. Marine Corps will have a new way to deal with small UAVs. The service has chosen Allen Control Systems Bullfrog Autonomous Weapon Station for incorporation into the Light Marine Air Defense Integrated System, L-MADIS, as part of its ground-based air defense GBAD modernization effort. Under the integration, the AI-enabled remote weapon station will be armed with the M240 machine gun, enhancing L-MADIS with an autonomous capability designed to counter emerging low-altitude aerial threats. Viewers may note, the service has requested more than $1 billion for its GBAD portfolio in its fiscal year 2027 budget, underscoring the importance of expanding layered air defense capabilities capable of defeating increasingly sophisticated unmanned systems. Mike Wior, co-founder and CEO of Allen Control Systems, said in a press release, "The Marine Corps requires the most sophisticated and accurate possible capabilities to carry out its critical missions." In this video, Defense Updates analyzes how Bullfrog with L-MADIS will provide U.S. Marines a cheap way to kill small drones. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Recent conflicts have fundamentally reshaped military thinking on the role of unmanned aerial systems. The war in Ukraine, along with Iran's extensive use of drones and loitering munitions across the Middle East, has demonstrated that inexpensive unmanned platforms can achieve strategic effects previously associated with far more sophisticated weapon systems. Ukraine has repeatedly employed first-person view (FPV) drones, costing only a few $100s to destroy armored vehicles worth millions. At the same time, Russia's long-range Shahed series attack drones have forced Ukraine to expend valuable air defense resources to protect critical infrastructure. Similar trends have been observed in the Red Sea, where Houthi drone attacks have compelled Western naval forces to launch high-cost interceptor missiles against comparatively inexpensive aerial threats. These experiences underscore a fundamental shift in air defense requirements. Future systems must not only deliver high levels of accuracy and reliability, but also be affordable enough to engage large numbers of targets during sustained operations. Scalability and cost-effectiveness are becoming as important as traditional performance metrics. The financial imbalance between attackers and defenders is particularly concerning. Many one-way attack drones can be produced for tens of thousands of dollars, or in the case of FPV drones, only a few $100s, while the surface-to-air missiles used to destroy them often cost hundreds of thousands or even several $1,000,000 each. The logic is simple: using expensive interceptors to deal with cheap drones is unsustainable. This unfavorable cost exchange allows even a technologically less sophisticated adversary to impose significant economic strain simply by launching large drone swarms. A gun-based system that uses bullets to take out drones provides a logical alternative. MADIS represents the United States Marine Corps' first dedicated mobile short-range air defense, MSHORAD, capability designed specifically to protect expeditionary forces against modern aerial threats. Mounted aboard two 4x4 joint light tactical vehicles, MADIS operates as a complementary duo. MADIS Mark I is for kinetic engagement, whereas MADIS Mark II is for command and control and situational awareness with radar and soft kill with electronic warfare. MADIS Mark I has a turreted Kongsberg Remote Weapon Station, RWS, hosting an XM914 30mm automatic cannon alongside an integrated pod carrying 4 Stinger surface-to-air missiles. The cannon is meant for countering drones, helicopters, and lightly armored ground targets, whereas the FIM-92 Stinger is for longer-range engagements against aircraft and larger unmanned systems. Importantly, a coaxial M240 7.62mm machine gun provides additional close-range defensive capability. In essence, MADIS Mark I configuration positions the M240 7.62mm alongside heavier ordnance to create a layered, multi-tier threat response. This is where Bullfrog comes in. Bullfrog is an autonomous weapon station developed by Allen Control Systems that combines artificial intelligence, computer vision, and precision robotics to convert conventional firearms into highly automated counter-unmanned aerial system, CUAS platforms. The variant selected by the U.S. Marine Corps is armed with the M240 7.62mm machine gun, providing an affordable and scalable solution for engaging low-altitude aerial threats. Powered by a standard 24-volt DC electrical supply, the system weighs between 165 and 300 pounds, depending on its configuration. Its relatively low power requirements and modular architecture allow it to be integrated across a wide range of NATO land vehicles, as well as maritime platforms with minimal modification. Unlike many traditional air defense systems, Bullfrog relies exclusively on passive electro-optical sensors rather than radar for target acquisition and tracking. This passive approach significantly reduces the electromagnetic signature of the host platform, improving survivability by avoiding radar emissions that could reveal its position. Mechanically, the weapon station is engineered to achieve a pointing accuracy of better than 1 minute of angle, less than 1 MOA, enabling highly precise engagements against small, fast-moving aerial targets. Once a target has been detected and tracked, the system's AI-driven predictive algorithms rapidly generate a customized ballistic solution by accounting for the drone's speed, direction, and trajectory. This allows the weapon station to maintain an accurate firing solution even against highly maneuverable targets. Although Bullfrog automates target detection, tracking, and aiming, it retains a human-in-the-loop architecture. The operator must authorize the engagement before the system opens fire, ensuring compliance with existing rules of engagement while dramatically reducing the cognitive burden associated with manually tracking and engaging small, high-speed drones. When equipped with the M240 machine gun, Bullfrog can deliver a cyclic rate of approximately 850 rounds per minute, providing the volume of fire necessary to defeat small unmanned aircraft. Allen Control Systems has also emphasized the system's exceptionally favorable cost-exchange ratio, stating that the cost per successful engagement is measured in the low tens of dollars, with ammunition representing the overwhelming majority of the expense. This makes Bullfrog a compelling alternative to missile-based interceptors when countering large numbers of inexpensive drones. The integration of Bullfrog into the Marine Corps' L-MADIS platform aligns with the service's broader transformation under the Force Design 2030 initiative. The strategy represents the most significant restructuring of the Marine Corps in decades, shifting its focus from conventional, heavy formations toward lighter, highly mobile forces designed to operate in contested maritime environments. As part of this overhaul, the Marine Corps has retired its M1 Abrams main battle tanks, reduced portions of its traditional artillery and aviation structure, and redirected resources toward capabilities such as long-range precision fires, unmanned systems, electronic warfare, and integrated air defense. The savings generated through these force structure changes have been reinvested in building an expeditionary force optimized for Expeditionary Advanced Base Operations, EABO, particularly across the vast island chains of the Indo-Pacific. Within this operational concept, L-MADIS has become a critical capability. As the Marine Corps' lightest and most deployable counter-unmanned aircraft system, L-MADIS is designed to accompany maneuver forces while providing continuous protection against the rapidly growing threat posed by drones. Integrating the Bullfrog autonomous weapon station significantly enhances the platform by giving the M240 7.62mm machine gun a smart fire control architecture. Bullfrog has already attracted considerable interest across the U.S. defense establishment. The system is currently fielded or under contract with the U.S. Army, the U.S. Navy, U.S. Special Operations Command, and international partners including South Korea and the United Arab Emirates. For the Marine Corps, the immediate priority is integrating the technology with L-MADIS and validating its performance under realistic operational conditions. If the prototype program proves successful, The same architecture could be adapted to other Marine Corps and Joint Service platforms equipped with the M240 or comparable machine guns. The initial prototype contract is valued in the low single-digit millions of dollars. Perhaps Bullfrog's greatest strength lies in its pragmatic design philosophy. Rather than introducing an entirely new weapon system with unique logistics, ammunition, and training requirements, it leverages equipment already deeply embedded within Marine Corps operations. The familiar M240 machine gun remains the weapon. Standard 7.62 millimeter ammunition remains the ammunition, and existing maintenance procedures continue to apply. The broader investment strategy reflects the urgency with which the Marine Corps views the evolving drone threat.